Assalamualaikum and hello to everyone. My name is Faris bin Ahmad Taufik Esri with material ID 2019-2508 from class J4AM 31103. So this video is about straight beam experiment. So the discussion from the assignment, the calculation result and the standard value is different. This is because there is error occurred during this experiment. When doing manual calculation of the experiment, it can lead to slight error if not cautious. In other case, equipment can also lead to error in the data analysis and not adjusted properly. Material also will act differently in different surroundings, for example, different temperature. So that the value of bending stresses and shearing stress will vary with the loading position of the beam. When the applied force change location of the beam, the stress will also change. From this experiment, steel will be stronger than brass. This is because steel can hold more stresses than brass can in both normal stress and shear stress. There is no difference between stress measured at the top of the beam and at the bottom of the beam. This is because from the diagram we will take the highest value and modulate it to make it positive. The stress will stay the same and it will be no changes.
Discussion 1. After the experiment ended, we can see a lot of differences between the calculation values and standard values based on the reaction forces, bending, and shear stresses for each specimen. This situation may happen because there might be an error while conducting the experiment, and also miscalculation may easy to happen when we using the calculation manually. The apparatus or equipment may affect the results and also the surrounding of the lab. Discussion 2. The relative importance of bending and shearing stresses vary with the loading position of the beam because the location of the forces will affect the value of the stresses. When location of the forces on the beam change, the value of the stresses also change. Discussion 3. Based on the results of the experiment, steel is much stronger than brass. The value of the bending moment and shear stress for steel is higher than the value of bending moment and shear stress for brass. Discussion 4. Not at all. There will be no difference between the stresses measured at the top of the beam and the same location on the bottom of the beam. This is because both of the stresses are at the same location, even though there will be a positive or negative value based on which surface of the beam applied the stresses. The highest value must change to positive.
The result and the standard value is different because there was error happening during the experiment. Error can occur if the experiment done without cautious and focus. Other than that, surrounding factor can also affect the result of the experiment. The relative importance of bending and shearing stresses vary with the loading position of the beam. It is because the stresses will change if the force applied change location. Steel will stronger than brass in this experiment. Steel can hold more stresses than brass in both normal stress and shear stress. There is no difference between the stresses measured. It happened because the highest value with modulus in the diagram will positive. There is no change in length and area causing no stress difference.
The conclusion from this experiment is that we can determine the reaction force, maximum bending stress, maximum shear stress in the straight beam from a bending test of tested specimen. The comparison of experimental reaction forces with the theoretical values for a loading on the straight beam was obtained. Each type of specimen have different value of stresses. That's all from me. Thank you.
Conclusion. To sum up, after all the experiment and procedure done, we can determine the reaction force, maximum bending stress, and maximum shear stress in the straight beam from a bending test of each tested specimen. There are slight errors when conducting the experiment, but the value is acceptable. Each of the specimen has their own value. We can also compare the experimental reaction forces with the theoretical values for a loading on the straight beam. The comparison was achieved successfully.
For conclusion, we can obtain the reaction maximum bending stress and maximum shear stress from the experiment. The result from the experiment will be slightly different from the standard value due to the manual calculation error and many more.